Hello world, it's RationalPi and we're here today for another episode of Avorion. And what we're going to do today is we're going to start our shipbuilding series, but I'm going to give you a little bit of a mechanical engineering lesson. I already have my bachelor's degree in mechanical engineering, and this is going to be the first time I ever get to use it in a practical purpose, playing a spaceship related video game, so that's exciting. So, as you can see here, this is the shipbuilding mode of Avorion, and as you can see there's a lot of different parameters there on the right hand side. And we're going to walk through those, and I'm going to give you a little bit of knowledge. I'm going to drop some knowledge on you. So the first thing I want to talk about is relation of position, velocity, acceleration, so on. So the position is obviously where you are. Okay, that's pretty simple. Velocity is if you want to go from point A to point B, how long does it take to get there? And the units of that is meters per second, or it's length over time. Pretty simple. Everybody should understand that. Miles per hour, if you're driving 10 miles per hour, you're going to drive 10 miles in 1 hour. That's why when they say if you drive 60 miles per hour, you're driving essentially 1 hour per minute. Okay, so acceleration is that same idea. It's the rate of change due to time of velocity. And its units are meters per second squared, or meters per second per second. So one way you can envision this is if you're traveling 30 miles per hour and you're going up to 40 miles per hour over a time of, let's say, 5 seconds, then that's a difference of 10 miles per, 10 miles per hour divided by 5 seconds, or your acceleration is then 2 miles per hour per second, really. I should have used SI units. SI units is what most engineers use, by the way. And SI units is what you're going to see here, except for the tons, when we'll talk about it in a second. So anyway, there's more parameters past acceleration. There's jounce or jerk. There's snap, crackle, and plop, which I believe are the 6th, 7th, and 8th derivatives due to time, but we're not going to get into those. If you understand position, velocity, and acceleration, then you can figure out the others just based on those. So let's go ahead and take a look at, we have the hull and shield, and those are just standard hit points in this game. Just as you would in a RPG game, you have so many hit points before you die. Now I want to talk about something. In the real world, when you're developing a ship of some sort, the position in which you have the smallest surface area is going to be one of your weaker points. So if you build a ship and you have this big wide fuselage, which is the body of the ship, and then you have these two flanges coming out, or like arms, and then you have these wide arms at the end, or these wide areas at the end of the ship. These connectors, these flanges, are going to be the weakest point because they only have this much surface area if you look at it face on. And it's going to be a lot weaker in those spots than others. So I'm interested to see if that's how it's going to play along in this game too. I don't know if each block has its own HP, and if you focus on the small areas of the ship, will those be the weaker areas of the enemy ships or what? But let's go ahead and move on to mass. Obviously mass is the density multiplied by its volume. So that's doesn't make a whole lot of sense. And I don't want to say it's how much something weighs, because weight is reliant upon gravity. And obviously since we're in space, gravity doesn't have any bearing over what we're doing. So I want to transition that to a next point. Whenever you're flying an airplane, let's say in the Earth's atmosphere, there's 4 principal forces that are enacting upon the plane at any given time. So let's say your plane's flying along this way. This way there's going to be air resistance, otherwise known as drag. There's going to be your thrust from your engines. There's going to be lift generated by your wings, and gravity or weight going downward. When you're in space, 3 of those forces are negligible. And those are, you're obviously not going to have any lift because you're not going to have any air resistance giving your wings lift. There's going to be no air resistance providing drag, nor is there going to be weight due to gravity. So you only have thrust, and if you're only thrusting this way, how are you going to stop? You're just going to keep going that way forever due to Newton's first law. So what you have to do is you have to create brake thrust, or thrust facing the other direction. And that's what you see, thrust and brake thrust right underneath mass when you're looking at the Avorion screen here. So thrust and brake thrust are actually forces, and force is mass times acceleration. So what you see here is that meters per second that you see next to thrust, that's actually the acceleration. But since you have the mass right above it, you can derive the actual, ooh, my computer went off. But you can derive the actual thrusting force by multiplying the mass, which is the 23,949 tons, times its thrust acceleration. There you go. And brake thrust is the exact opposite. It just faces you the different direction. So max velocity is what's the max speed you can go, and it's based off of that ability of thrust. It's not, you don't automatically just go at your max speed. You start at 0, and as your engines start thrusting you forward, your speed climbs until it reaches the maximum output that your engines can thrust, and then you're going to meet that maximum velocity. So what yaw, pitch, and roll are just positional changing of your spaceship. So let's say your spaceship is moving this way towards the camera. Yaw is this motion here, translating left and right. Pitch is moving up and down, and roll is like do a barrel roll, and you do this kind of motion, or this. So that's what yaw, pitch, and roll are. And those units are radians per second, or how fast along the center of the spaceship does it actually do this motion, or does it do this motion. It's all based on the center of the spaceship. It's not the exact center of the volume of the spaceship, it's the mass center is where everything's based from. So if you have a weird looking plane, you got to figure out where the mass center is before you can figure out where you're going to calculate your yaw, your pitch, and your roll. Hyperspace cooldown, hyperspace reach, and radar reach, those are just in-game structures. They're not real-world type of units. They're not real-world type of parameters. And those are just based on the map and how much strength your hyperspace drive has on your specific ship. And we'll go over that a little bit, but that has no real-world significance that we're talking about here. System upgrade slots, cargo hold, crew quarters, and fighters are also in-game constructs. Free arbitrary units, armed turrets, unarmed turrets, or firepower are just based on, you know, what kind of firepower you have on your ship. I don't know what that unit is OM under firepower. I'm definitely going to do a little bit of research to see what's going on there. And then you have the crew, you have the required gunners, required miners, required engineers, and required mechanics. And then let's go back to energy. So a joule is simply a force over a distance. So I have my mouse here, and I'm applying a force. Let's pretend it's on my table. I have a force pushing on my mouse over a certain specific amount of air, of distance. Get out of here, HP support. Nobody wants you. Anyway, so what the joule is that force applied over a distance, and what a watt is that joules, which is the force over a distance, and that's divided by time. So it's basically the velocity of which you're forcing something to move. Get out of here, HP support. Nobody wants you. Jeez. Well, that's just going to be there for a second. I'm going to keep talking, so you can get over it, HP. Leave me alone. I don't want you. Anyway, it always pops up every single time I try to record, but that's okay. We're just going to keep talking because we're just talking about some awesome engineering concepts. So that's what joules and energy are. Joules and watts are. Joules and watts are common units of energy. With watts, you may have heard of like kilowatt hours. That's based off of how much energy you've used over a certain amount of time, and that's how most energy companies charge you based on your kilowatt hours. And so that's what your generated energy, that's how much energy your ship can produce, your required energy, how much it's required to run, and how much energy you're able to store. And your storable energy is based upon just the total amount of energy you have, and then the required energy and the generated energy are based over time. So these are all the different parameters that you have to think about whenever you're designing your ship. And in the next video, we're going to start playing around with the blocks. What happens if you resize the engines? What happens if you place an engine here, place an engine there? And we'll start seeing a lot of the plus minus. You may have plus mass minus thrust. Because the most important thing you have to worry about whenever you're designing an airplane or a spaceship is mass. And the reason that is because, think of it this way. Whenever you're trying to thrust something forward, if it weighs more, the ability for it to move, it'll be slower to reach that max velocity whenever it weighs more, because it has to create enough thrust to be able to push it forward to that maximum velocity amount. So what I'm expecting to see is whenever I increase the mass of the ship, the thrust will go down unless I add more boosters and more engines to it. And so mass is going to be playing a part in almost every decision we make, at least theoretically, at least from what I learned in my classes. Mass is going to play a really big part in how we design our ship. And I'm assuming with this basic ship here, the creators, Kunsky, went in and created a very basic, usable ship for us to use in super action mode. So I want to go ahead and end our episode here. I hope you learned a little bit of something. If you want any more information, please comment below, or I can do another video on this if you'd like, with more information and more in-depth information on how to actually calculate these things. My name is RationalPi. This is the first episode of the shipbuilding in Avorion. I'm loving this game. I love the detail behind it. I love the science behind it. As a mechanical engineer, I love it. I love it. I love it. So again, I would greatly appreciate a like and subscribe, and I'll see you guys in the next video. Have a good one.